Okay, so as you are aware, as we look ahead, as you look ahead in this schedule for this week, your first if you want to call it on equations, your first evaluation is on Wednesday. Otherwise, it's our second one this week, or for this chapter. And I've always tried to get the track schedule up there. And I really don't think it affects this class quite so much. There are a few days where you might be leaving at around 11 o'clock. So as you're... Okay, so what you would see, obviously, you have the day of the week, the date, the name of the track meet, the location, the time it starts, and then the time that you leave. That's how it's presented.
The time that you leave
is on the far right. Okay? So I know that the track schedule sent out, it just gives you the date. I just like knowing the day of the week. Okay? So that's why you see that up there, because it helps me and it probably helps you too. Okay. So as you look at this, I better take roll first. Okay, so this is where we left off with last time. All right? So when you're choosing coefficients, okay, you're just putting, those are the large numbers that you see in front of an equation or a reaction. I don't quite have them all up there yet. It's still work in progress. Okay? All right. Okay. So as we start classifying these, okay, we're talking about combustion reactions. It means you have carbon, well, if you let me explain it, okay, it means you have a hydrocarbon, hydrogen and carbon, just means that it's burning. Okay, and you always get the same byproducts in a combustion reaction. Carbon dioxide and water. Every time. At least for our purposes. Because what happens, okay, let's say, for instance, you have a machine shed that has lots of birds in it. You don't want to shoot them because you don't want to damage the building. You don't want to damage equipment. Okay? And then what you can do, maybe start and run some equipment in there. Your tractors, a few vehicles. Okay? Shut the doors, and then we know from the products of combustion are what and what. What does it tell you? Carbon dioxide and water. So what's going to happen is eventually all the oxygen is going to get used up. Your equipment is still going to go through the process of combustion, but carbon dioxide loses in oxygen, starts to turn to carbon monoxide. Okay? So then when that happens, anything that's inside of there is probably going to, okay? Anything that's inside of there is probably going to first pass out and then asphyxiate. What does that mean to asphyxiate? Does anybody know? Does anybody know? It means the body runs out of oxygen. Asphyxiate. So then what happens is carbon dioxide changes to carbon monoxide, and if you wanted to open up the tailpipe or exhaust, you see soot in there. That's just pure carbon. So it just depends how much oxygen's available. I can't hear you when I'm talking.
You said it's good to start your car
Okay?
That's true.
How many of you have been fairly confident and comfortable with the equations that have been, we haven't gone over them yet, and I won't do so unless you ask. Yes?
I forgot what you said. He's doing good. I'm doing good.
All right. So, and we've said this before too, okay? When it comes to when it comes to a synthesis reaction, you're actually making something. This is the simplest of all the reactions. And one way to look at this is, in a synthesis reaction, you are making something way more complex. Zoom tight. You're making something way more complex than the parts that make it. Okay? So, the first thing that you said comes to mind is photosynthesis. Okay? Okay, does everyone have this content that wants it? Okay. Okay. So, as you look at these three reactions, what are they, do you think? That doesn't answer the question. Which one or ones are combustion? Why is that correct?
Because they have carbon, oxygen,
Yeah, because it's got a hydrocarbon in it. Okay? So then this does not have a hydrocarbon in it. Okay? So therefore we proceed forward. The symbol for calcium is what? Okay? And I should have put this up here for you. If this is a synthesis reaction, what did it tell you a synthesis reaction is, or what did we tell you? Don't know? What about your sitting at your table? What do you have to say? What's a synthesis reaction? Why don't you look at what you wrote down? Okay? Your voice has changed. Said his voice has changed. So what is it then? Okay. So in this case, what's going to be on the right-hand side if these two substances combine? I heard Ca. Okay. The charges would not change. What's the charge of calcium? What's the charge of a bromine or a bromide ion? Okay? Since those don't add up to 0, what do you need to do? Okay?
Is it bromine or bromide?
It's bromide now since it's an ion. Okay. Is that right?
No.
It is not. Bromine needs to have a 2. Why is that?
Because the balance of the equations don't add up.
Now, human nature as it is. Human nature is curiosity. Human nature is a lot of other aspects. Okay? It is. Now, with that, okay, human nature is going to say, well, I did not know that bromine was diatomic. How do you know that bromine's diatomic? For one, we're telling you. How else do you know? It's in the 7th column. Yes. Yes. Okay. So then, this has to have a 2 behind it. Okay. Now, how do you go about proceeding to balance this? You Google it, huh? Okay.
I don't think you need to Google it.
I don't think so. It's already balanced. Because nothing's changed. Right? Okay, so this is already balanced. A synthesis reaction takes 2 substances and makes something more complex. Okay. What do we get up here? These are both combustion reactions. What do we get on the right side? No. In a combustion reaction? No.
CO plus H.
No.
Wait, OH plus C.
No. I know you wrote it down. What did you write down for a combustion reaction?
HO plus E.
No.
Occurs when something burning.
I know. What else?
Main types occurs with
Gives off carbon dioxide and water.
So wouldn't you be led to believe that this is carbon dioxide and water? All right.
CH2O. You have friends? Chris, do you?
Now, as you look at this, okay,
His friends with that purple hair chick in our class.
put the chair down. Okay?
So you were staring at her a second.
Now,
You were.
so now, which one of these two equations would you rather balance?
No, the top one is odd.
Top one is odd. What does that tell you?
It's easier to do.
Okay? Do we need to double this then? No. Okay? So you can just go ahead, write on. Do you want these wrote out with what's on one side of the equation and what's on the other? Okay. Okay, so what are some elements that we've got?
Carbon.
Hydrogen.
Hydrogen. Oxygen.
That's it. That's
Carbon's left.
Three.
Right.
One.
Hydrogen's
Eight.
left.
8.
two.
2.
Three.
2.
Okay. Now, we said if that number's odd, why is it so much easier to balance?
Have to double it.
Okay, so we can just go ahead and put a 3. Okay?
6.
Okay? What does that do to your oxygens now?
7.
Balance is that.
Okay? So let's go ahead and deal with our hydrogens. We've got 8 and 2. Okay? So how many oxygens are over there? Okay? 10, right?
Yeah, I thought there was 2 back there.
Okay? Does everyone understand why that is 10? You don't understand what? What part now? What part don't?
Oh, never mind.
So now we're good. Okay?
Whoa, she just left? 50?
Okay. So that's now balanced. Now, what does that mean if these are even now? Chair down. And get your feet down. Okay.
Jeez, Nick, you must have been doing some custom work, them pants. that
What is-
heavy.
What does it mean if it's even?
You have to double it.
Okay. So,
If it's even, it's not odd.
okay, so for this bottom reaction, what do we got? Carbons left.
4,
Carbons right.
1,
Hydrogens left.
8, 10 maybe.
Hydrogens right.
2,
Oxygens left
2.
and right. Okay. Do you understand where those numbers come from? So, what are coefficients in a reaction? There's a 10 right there. Okay? So, we understand where these are coming from. So then, by trial and error, you are going to use coefficients, and those are what type of numbers? The big numbers, because we're just dealing with subscripts right now. These are all just subscripts. Okay, so you had said if this is even, what do you need to do? Okay. 2 times 4. Okay. So how do we get 8 over here? Okay. All right.
Isn't it at 26 oxygen though? No, on the right. Yeah.
It is. Okay. All right. So we will pick up with this tomorrow. We're going to wrap up the launching of the rocket. So we'll catch up to you next time.